Good afternoon, everyone. Welcome to this Talmo online seminar looking at accessibility in mathematics and statistics. Really delighted that we have Chris Hughes giving the seminar today. Chris is from the School of Maths and Stats at the Open University, and he's the accessibility lead within the school and has got some real experience and expertise that he's going to be sharing with us today, with some kind of real practical advice that we can all look to use within our teaching. Just to mention a big thanks as well to Kevin and Rachel, who you will have heard from just there, for all of their work in helping set up this series as a whole. This is, I think, what, fourth event, I believe now. I think there's been so many we've lost track, and please do check out the Talmo website, because recordings from previous events are all on there and are available, plus a whole array of different resources as well. Just to be clear, this event is being recorded today, so if you don't want to be recorded or don't want to be identified, change your name within the chat box. Or feel free to leave the seminar, to leave the Zoom version and watch the YouTube live stream as well. Just to a couple of sort of matters of housekeeping, really. We're quite keen to have some interaction today through the Zoom platform. If you've got sort of chat, any comments, I think many people have already found the chat function. I guess that's how we found out Gary's on holiday. Do sort of put any general comments into the chat function. Do be aware that you need to make them either available to all panelists, if you just want it to go to panelists, or to all panelists and all attendees as well. So just be aware of those particular settings, but we will also make the chat available as well. Chris has very kindly agreed to answer questions, and we'll be kind of facilitating that on his behalf at the end of his presentation. So please do use the dedicated Q&A feature for logging your questions there. That will just make it easier for us to kind of be able to pull out questions and see exactly the kind of things that you want answering. We won't be using the kind of the raise hand facility or inviting any interaction, because on a webinar this size, it'll become a bit too difficult to manage. Just to say, next week we have an afternoon event which looks at the teaching and learning of statistics online, and that's been organised by the RSS education group. Although it is focused upon statistics, the ideas are equally applicable to the mathematical sciences, so that's another event that's well worth looking out for. Please do sign up to talmo.uk if you haven't already, and we'll make sure that you'll send details. Then we'll all be taking a well-earned summer break, which I know Kevin, Rachel and I feel is incredibly well needed. But we'll be back in September with some more events as well to help us get started, ready for the start of the next academic year. I mentioned this before, but please do look at the website. Lots of how-to videos, short guides, case studies. If you see interesting resources, send them across to one of us. Our email addresses are there. Please do get in touch, and we'll look to make resources available. But other than that, I think it's a great pleasure to be able to now hand over to Chris, who's going to take the lead on this webinar. So Chris, thanks for being involved, and over to you.
Fantastic. Thank you, Michael. Thank you, everyone. Just a quick audio check. Michael, can you hear me okay?
Perfectly, Chris.
Great, thank you. Can you see my screen okay as well?
And I can see your presentation.
Perfect. All right, thank you so much. All right, thanks everyone. So yeah, my name is Chris Hughes. I'm an academic member of staff at the Open University. I'm in the School of Maths and Stats, and I'm here today as the accessibility lead for Maths and Stats. I have a few intentions and goals, I suppose, for my session today. I'd like to set out a little bit about the structures that we have in place to support our disabled students within the school and how they connect with the wider institution. But I also want to focus on some practical aspects of accessibility that we provide for our students. I do consider myself very much a student of accessibility, and there's all kinds of things that I have yet to learn, but I'm really hoping that today I can share with you some of the things that I've been part of in learning over the last few years as accessibility lead. So I suppose in kind of framing the discussion today, I thought I'd start with these two quotes. The first one: people who have disabilities do not wish to be included. They wish it to be acknowledged that they already belong. So this is from Elizabeth Hastings, who was Disability Discrimination Officer in Australia in the 90s. And the second one is from Accessible Virtual Learning Environments, a technical report, and it says universities must make reasonable adjustments so that disabled people are not disadvantaged relative to non-disabled people. Further, these adjustments should be made in anticipation of the needs of disabled people, rather than only on request. And I suppose my intention in starting with these quotes is to try to say that my experience of working with colleagues across the Open University, and indeed outside of the Open University as well, has always been that we provide support and reasonable adjustments for our students because we believe that it's the right thing to do, and we believe that we have, a moral responsibility to do that. So we do it for, the right reasons. But I want to say that first, because the second slide that I have is a little bit about the legislation which kind of sits behind this. And at the center of it is the Equality Act from 2010, which brings together a wide number of pieces of legislation. Reference number 8 is particularly about public sector equalities. Reference number 13, public sector websites and apps, and the associated links in 14 and 7 is something that's particularly prevalent in our minds at the moment, the 2018 VLE legislation. If you only have time to view one of the links that I've put within this presentation, link number 4 is technical guidance on FE and HE. And this is a particularly practical document and contains specific examples of the types of reasonable adjustment that we might put in place for our students. If you're interested, link number 5 is the Open University Equality Scheme, and it maps out how the Open University aims to meet the Equality Act in the associated legislation. I'm sure that each of your institutions has, similar and analogous things. So I suppose one phrase that's come up already today, and one that we will be using a number of times, is the phrase reasonable adjustments. And this term is suitably flexible. And the definition, which comes from the Equality and Human Rights Commission website, link number 15, to avoid as far as possible by reasonable means the disadvantage which a disabled student experiences because of their disability. So there are all kinds of different types of reasonable adjustments that we might make. And indeed, I imagine that many folks in the audience today have provided reasonable adjustments for students in their journey. It can mean a variety of different things. It's a very flexible term. So it could mean something as straightforward as providing an extension on an exam or on a test, allowing more time. It could mean providing a scribe for a student so that they can concentrate during the lecture and then that person takes the notes. It could mean providing live captions or a transcript for a video afterwards, or it could mean something as technical as providing an alternative format for teaching materials that is available to assistive technology. It could mean a number of different things depending on the needs of the students. I suppose in trying to set the scene on this, and we will focus in and arrow in on maths and stats specific reasonable adjustments, but in trying to set the scene, I thought I might present some data from HESA, the Higher Education Statistics Agency. And this data is from the academic year 2018-19. And I'd encourage folks to go and pull this data for yourselves as well. I've provided the link, which is at hesa.ac.uk. And I've presented a table here that has 4 columns. In the first column is institution. In the second column is the number of students who have declared a disability. In the third column is the number of students who have not declared a disability. And in the fourth column is the total number of students. I've arranged this table and it's sorted by the number of students who have declared a disability. So it's not a comprehensive table because there are 169 entries in it. So I've just presented, 7 which would fit on this slide. And arranging it by the number of students who declared a disability puts the Open University at the top of this table, because in this academic year, 18/19, we had 27,300 students who declared a disability, which was 22% of the total. I will note here that there are institutions that have a higher proportion of disabled students, but I will also note that of the 169 institutions listed in this table, this 27,300 represents more students than 152 of those institutions have total students. So it's quite a figure. But I guess in talking about disability, well, it might be helpful to try to unpack that a little bit. And I thought that we might try and do that in terms of the ways that Open University students can declare a disability to us. And they fall into one of the, at least one of the following categories. Mental health, which can include anxiety, depression, obsessive compulsive disorder, post-traumatic stress disorder, eating disorders, bipolar affective disorder, and many others. Dyslexia, fatigue, pain, unseen disabilities, such as asthma or epilepsy, mobility, other disability, autism, manual skills, hearing, speech, personal care, and visual. And I imagine that you would have similar classifications of disability at your institutions. And I suppose understanding the different type of reasonable adjustment would depend on the category of the disability and the particular needs of the students, which we'll come on to as we move forward today. I think this is now probably the time where we start to talk about the specific challenges of accessibility when it comes to maths and stats. Because as we know, as educational professionals within maths and stats, there are particular learning elements and features of our discipline that, while they're not unique to our discipline, they are prominent and prevalent. So on this slide, I have three elements. I have a figure, I have a table, and I have a piece of mathematical content. The figure appears to be perhaps some kind of rational function. It has two branches and it looks like it has a vertical asymptote at x equals 2. Looks like the left-hand branch is increasing, goes up through -1, 0 through the vertical intercept and up towards the vertical asymptote from the left. And the right-hand branch looks like it starts from the bottom of the graph to the right of the vertical asymptote and goes through 3, -8. We have tables which we use for numerical data and sometimes for algebraic data as well. So I have a table on this slide which has x and y values. The x values are 1, 2, 3, 4, and 5, and the y values are pi, e, 4, -10, and 17. But then, of course, prominently throughout the language of all of the education that we use is our mathematical notation, which we use as, lexicon throughout all of our education. So here I've just got a small example, the integral from a to b of x squared over 3 plus cosine of x dx. And these challenges, as I say, while not unique to the discipline of maths and stats, they are prominent within everything that we do, whether we're talking about examples, exercises, definitions, theorems, proofs, any one of the educational building blocks that we use. So I do hope to get onto some specific reasonable adjustments in a moment, but I think the first thing that I'd like to talk about is the Maths and Stats Accessibility Working Group that we formed in May 2017 at the Open University. So on this picture, I have I guess it's broken into two halves. It's broken into a student-facing half, and there are associated circles which emanate from it. And then on the left-hand side of the diagram, there are not student-facing halves. Now, my intention in showing this diagram to you is not to try to dazzle you with acronyms, because I'm sure that we've all got our own acronyms with our own institutions that we would love to use. But my point is mainly to show that the group exists, but furthermore to show that it is very much an attempt at having joined up thinking when it comes to disability support at the Open University. Furthermore, from here, this group reports upwards towards the senior members of the management team and associated academic management teams at the institution, who can then report upwards from that. And there are several kind of ideas and focal points of the group. We try to use it firstly as a forum to share best practices and lessons learned, in particular, surrounding processes and sometimes even individual student cases. We also use it as a forum to highlight challenges or things that might concern us coming forward. So for example, at the moment, prominently in our minds is the 2018 VLE legislation. And as I say, from there, we also aim to, to share best practice, but also to make sure that each part of the group understands their particular responsibility when it comes to supporting disabled students, and ensuring that that responsibility doesn't fall through the cracks, and making sure that every person kind of knows what it is that they are responsible for. So I will now go through these acronyms just for completeness. So SRSC stands for Student Recruitment and Support Centre, and this represents our student support teams who provide information, advice and guidance to our students throughout their academic journey. Our disability support team, well, their responsibilities include writing profiles for the students and detailing the types of reasonable adjustments that those students might make. I've put the tutor in a dashed circle because we don't have explicit tutor representation on the group, but we do have implicit tutor representation because some of the other group members are actually tutors. Staff tutors, an analogous comment is made there. DAS, Disability Advisory Service, we have our visual impairment specialist on the group, which is vital, as you might imagine, for maths and stats. We have representation from the library services, which, as you can imagine, gets us connected with all kinds of external facing publishers. DSS, Disabled Student Services, who are responsible, among other things, for providing audio versions and alternative formats for our students. And then on the non-student facing side of things, we have our accessibility coordinator for maths and stats, representation from our cross-institution SEGA group, securing greater access. We have academic representation from the module teams who are responsible for the production of our module materials. And we have school academic leads, which is me. And as I say, outputs from this group and any concerns or any successes are reported up through the school. So it really helps to have that layer of communication. So I thought I might move on now and focus on some particular reasonable adjustments that, that we do put in place for our students. And we're getting into kind of a bit more of the maths and stats specific part of this session now. And in particular, when we think about the types of disability that we detailed previously, there are many types of reasonable adjustments that we can put in place. And many of those reasonable adjustments can be catered for and accommodated by others around the institution without necessarily a technical solution. But there are a set of reasonable adjustments that do require technical input and academic input as well. And it's mostly focused, in our experience recently, mostly focused around those students that are blind or visually impaired or otherwise print disabled. So I'm going to start with figure descriptions. So figure descriptions, the idea is to convey essential information to a student who cannot see it in order for them to achieve the learning outcome intended by the author. So we provide figure descriptions for every single one of the figures that we produce, both for our module materials and for all of our assessments and assignments. And I've got a couple of examples here of figure descriptions that I thought we might go through. I think the first thing to say is that the mechanisms that we have for producing figure descriptions, which we do at quite a large scale, we rely on contracting members of our associate lecturer community. So the example I'm going to start with is from one of our third level modules, which is called M337, Complex Analysis. It's a 30 credit module, which represents a quarter of a full-time student's workload. And just to give you an idea of the scale, that module had over 1,000 figures within the module, and we had a team of 3 tutors work on producing the figure descriptions. And we have a primary and secondary author mechanism in which the tutors create and then review each other's work. And working collaboratively, those 3 tutors were able to produce the over 1,000 figure descriptions in about an 8-month period. And that was in addition, that was part of their workload. It was on top of, their teaching responsibilities. So the very first figure description I've got is from M337, and I've put a figure on the screen, and now I'm going to read out what the figure description is. This figure shows the unlabeled complex plane and is concentrated in the first quadrant. It shows a contour, capital gamma, marked with an arrow in an anti-clockwise direction. The contour is made up of 3 line segments. The first, labelled capital gamma sub 1 from 0 to the labelled point 2. The second, labelled capital gamma sub 2 from the point 2 to the labelled point 2 plus I. And the last, labelled capital gamma sub 3 from 2 plus I to the labelled point I. There are solid dots at 0, 2, 2 plus I, and I. So there are a few things to kind of unpick from this figure description. The main thing that we aim for is to have the figure descriptions be concise, precise, and detailed enough so that the students can get the necessary information from it. But one of the things that might stand out to you here is that the mathematical content has been written out in plain text. The reason for that is that we deploy our figure descriptions in a variety of different ways, and we want to ensure that we can do so as robustly and confidently as possible to ensure that the student who is going to use them has the greatest chance of being able to access those figure descriptions. That may change in the future for reasons that we might get to towards the end, but at the moment this is the way that we do this, and there's a great reference document that we use called Larry's Speak Easy, which talks all about writing maths in words. I do have another example of a figure description, and I suppose I want to give this one because these figure descriptions do give the authors the opportunity to have a little bit of expression. And that's something that we encourage from any one of our teaching community, right? We encourage people to give their own take and their own expressiveness on it. So I have example 2 here. This is again from M337, and I've presented on the screen a black and white picture of Gaston Julia, and the figure description is as follows. This is a black and white photograph of the French mathematician Gaston Julia. Sections of the photograph are faded, but it shows a strikingly handsome young man with short, dark hair, looking directly at the camera. He wears a dark, double-breasted jacket and is posing stylishly as he plays his violin in front of a wood-panelled wall. So some of the figure descriptions are, fairly kind of logically ordered, but some of them do allow for some expression. And as we're talking about presenting figures to students who may not be able to process them visually, one of the other options that we are very keen to pursue whenever possible is to provide tactile diagrams to our students. Now, I can't present an electronic tactile diagram, but I do have one that I'm going to hold up in front of the screen, which, from your perspective, will most likely just look like it's a sheet of paper. And it is, in many senses, just a sheet of paper, but it's special paper. It feels almost plasticky to the touch, and it's swell paper. The paper has a solid black dot in the top left-hand corner to allow the user to orient themselves. And indeed, the markings on the paper are raised so that when a student accesses the paper by touch, they are accessing raised lines and raised dots on the piece of paper. At the top of the piece of paper is a caption for the graph. On this particular instance, the caption is written in using English words, using the English language, but this is quite an early production of this particular one. And in fact, the student with whom we're working with for providing these would actually prefer it to be written in Braille, and that's something that we would accommodate in the future. I will say that I won't claim that we provide tactile diagrams for each and every single one of the figures. In relation to M337, for the over 1,000 figures, we don't have the capacity to provide, over 1,000 figures. And indeed, from our experience of working with the students who require these tactile diagrams, they may not necessarily wish to have all 1,000 figures. So in such cases, we work together with module teams, and in recent cases with the student as well, to figure out what would be a good and helpful representative sample of the number of figures that would be helpful in providing them as a tactile diagram. So on to example 3, and this example is about the language that we use. So last week on the Friday afternoon Talmo conference, which was hosted by Sue Pawley, Hilary Holmes, Claudia Thomas and Katrina Rogers, part of their talk touched on the language that we used in terms of tutorials, and they talked about it in terms of the positive, supportive, encouraging language that we try to use to encourage our students to attend tutorials online. And I guess I'd like to come at the language that we use now from an accessibility point of view. And for the first time in quite a few years, I'm going to try and present some maths online, which, given the current audience, I find quite intimidating. And I'm sure that you'll alert me to any mathematical howlers that I make. But my point is not about the mathematics that I'm about to go through. It's about the language that I'm about to use. So I imagine that many of us will be presenting mathematics or statistics online over the next few months, perhaps even longer. Perhaps in the form of lectures, seminars, tutorials, screencasts, videos, anything like that. And my assumption is that we would like to try to make the captioning or associated transcript available to the students. So I'm going to assume, and I know this is quite a big assumption, but I'm going to assume that the technical process for getting those captions or those live transcripts is just, you know, a closed box that works, and we've just got that working. And our only responsibility as educators is to provide the words. That's my assumption in what follows. And my intention in going through this example is to try to illustrate that we as educators are responsible for the words that we use and the language that we use. So I have this example and I'm going to go through it twice. And I have a point to make, which I hope will be made either as part of me going through it or otherwise explicitly once I've been through it. So I'm going to go through it, and here's the first time through. Right, good afternoon, everyone. Welcome to our session. We have a great number of differential equations to talk about today. I put an example on the screen for you to have a look at. Just have a think about it, and now we'll go through the solution. So we do recognize this as a linear differential equation from our module materials. So that means that we can use the integrating factor using the standard formula, and we get e to the x as the integrating factor. That means that we can now just plug this into the general solution, and we will get 1 over the integrating factor and then the integral of the right-hand side. And then on the second line, well, we can bring the integrating factor up into the numerator, we can perform the integration, and then finally on the last line, if we just multiply that integrating factor through, we get 3 plus c e to the negative x. So that's the first time through. Now I'm going to go through it again using slightly different language, and off we go. Right, good afternoon, everyone. We have some differential equations to talk about today, and the first example is as follows. Find the general solution of the differential equation dy dx plus y equals 3. Okay, so have a think about how we might approach that, and now we'll talk about the solution. So we recognize this from our module materials, in particular, Unit 8, Equation 19. We recognize this as a method. We can use the integrating factor method for this. So the integrating factor we represent by the letter p. So p of x is equal to x of the integral of 1 dx, which is just e to the x. And now again, using our module materials, Unit 8, Equation 20, the general solution will be y is equal to 1 over that integrating factor, so 1 over e to the x, multiplied by the integral of 3e to the x dx. So we can simplify this a little bit. We can bring e to the x from the denominator into the numerator, so that's e to the negative x, multiplied by, open bracket, 3e to the x plus c, close bracket, and then finally we can simplify that as 3 plus c e to the negative x, where c is an arbitrary constant. So my intention in demonstrating this example is to try to demonstrate that we as educators are responsible for the language that we use. So imagine that you are a student who is perhaps either deaf or hearing impaired, or perhaps blind or visually impaired, and you're relying on the transcripts or the associated captions that we use when we're presenting materials. Granted, the two versions of what I went through there, I would label as probably at, you know, the extreme end of things, But I hope you'll agree that in the first version, I kind of made quite a bit of assumption about people being able to access the materials visually, kind of using thises and that's, and perhaps not enough detail. And in the second version, well, perhaps I gave too much words. But I guess my intention in just demonstrating this is that you know, it's good for us to be mindful of the words that we use and the language that we use when presenting mathematical materials and the assumptions that we make about you know, our students being able to see and process information visually. And so on to the last part of my session, and this is where I'm really going to probably push the boundaries of online conference technologies. I've tested this twice now with Michael and Kevin and Rachel, and both times we were able to do it, but I know what technology is like, so it may not work, and I haven't bet the farm on this, so if this doesn't work, I've got backup plans, don't worry. But I'd like to talk about making our mathematical content accessible to users of assistive technology, and in particular those that are blind or visually impaired. Now, when I'm talking about assistive technology, I'm talking explicitly about screen reading technology. So names of such screen reading technologies include, but are not limited to, JAWS from Freedom Scientific, NVDA, Chromevox, VoiceOver from the Mac operating system, and so on and so forth. So as a visual user, I can process information by reading from a screen. I can read PDF documents, I can read paper documents, I can process information visually. But members of the blind and visually impaired community may not be able to do that and may access their materials using assistive technology, such as the screen reader. So what does a screen reader do? Well, if you imagine a piece of software that lives on your computer, and instead of, well, you fire it up and then it reads aloud what it sees on the screen for you. Now, you may imagine that for many disciplines that do not contain technical content, the screen reader will not struggle. It will be able to read out the words and the language used. But of course, we in Maths and Stats, we need to be very, very mindful of what we're going to produce, of the mathematical content and what we're going to ask the screen reader to do. So options for getting the screen reader to engage with mathematical content. Well, they include the following list. There's been some work done recently by a group from Turin on their accessibility package. And I should say that I am assuming that we're working with LaTeX in this. My assumption for that is that at the Open University, we work predominantly in LaTeX for our mathematical materials. And I've been led to believe it's a reasonable assumption to assume that many institutions across the UK would also use LaTeX. We're not going to focus on any other mechanisms for the moment. So that this accessibility package is something that you load in your preamble, and then you have the PDF document is kind of annotated in a special way. And I've had success in experimenting with their work. Other options include EPUB 3, and this is the preferred option from the DAISY consortium. And I've linked here to a seminar series, it's reference number 3. And I would highly recommend that, you know, if you get the chance to have a look at some of the recordings of some of those DAISY seminars on EPUB, I found them most insightful. But the method I'm going to focus on today is about HTML with associated MathML. So the question becomes, how do we get from our LaTeX source code into HTML with MathML? And then, well, really the main question is, can we get assistive technology to engage with that associated output? So in answering that question, I know of at least 3 methods for converting from LaTeX into alternative formats, and they include the following. So there's the Python-based Plastech tool, there is the Lisp-based Pandoc tool, and then there is the LaTeX-based Tech4HT tool. And you know, my view is that it doesn't particularly matter which tool you use, as long as we're testing, you know, the associated output. That's really all that matters. So I'm going to give a demonstration, I hope, with Tech4HT today. That's going to be my goal. So I'm going to start with a series of very small LaTeX files, and this is something that I hope that you can replicate on your own with your own LaTeX distribution. I use TechLive, but you know, everything I'm going to demonstrate up to a certain point is something that should be part of either TechLive or Mathjax or Mictech, whichever LaTeX distribution you've got. So the file that I'm going to start with, I'm going to do a few check-ins with Michael in just a moment. I've got my file browser here, and my file browser has 3 LaTeX files and then a mystery talmo.config file, which we'll come to in a moment. Michael, just to check, can you see talmo1.tech on your screen?
I can.
Thank you. Okay, and I'm assuming if Michael can see it, everyone can see it. So I've got a very minimal LaTeX file here. It's using the article document class. It uses begin document, and then it says hello Talmo, colon, and then it's got some mathematical content, y equals x squared. Now, as LaTeX users, we've probably produced PDF documents from LaTeX files before, and that's a fairly straightforward process. But our goal for today is to produce a different type of format, in particular HTML with MathML, and then to test it with assistive technology. So I'm going to be using Tech4HT, and in particular, I'm going to be using a piece of software called Make4HT, which is a build process for Tech4HT. It should be part of your distribution. It should be available within either TechLive, Mathjax, or Mathjax. So I'm switching to Windows PowerShell here. Okay, so the Zoom screen at my end is blocking up what I can see at the top of the screen, but that's all right. I'll be done with that in a moment. Michael, can you see PowerShell? Can you see the command line blinking?
Yes, certainly, Chris.
Okay, thank you. I'm just going to press return a couple of times. Yeah, that just gets me away from the Zoom thing that's up at the top of the screen. I'm going to check if I've got Make4HT installed. I'm going to type Make4HT -v for version. And this will tell me what version of Make4HT I have installed. It tells me that I have version 0.3e installed, and with reference to CTAN and indeed GitHub, you'll find that that is the most up-to-date version in July 2020. So what we're going to do is something quite straightforward. We're just going to type Make4HT, and then we're going to type talmo1.tech. And before I press return, I will just draw your attention to the file browser, which at the moment just contains 3 tech files and a configuration file. I'm now going to press enter on this process, and this should trigger Make4HT to get moving. Now, by default, Make4HT is not all that verbose in its output. On the screen here, I'm seeing some status updates, and then I'm seeing some evidence of the commands being called. There are options to change the verbosity of this and to have the information displayed to you a little bit more. And I would encourage you to have a look at the documentation for Make4HT to see more. So you can do that by typing tech.doc Make4HT, and that should bring up the associated documentation on your system. So be sure to take a look at that if you intend to explore this. So let's return now to our file browser. And as users of LaTeX, we're familiar with the many different files that LaTeX produces, you know, auxiliary files and log files and such. But what I do see in this file browser in particular is talmo1.html. This is optimistic. I'm going to click on this, and I'm going to open it in my web browser. And I see within Google Chrome, I see an HTML file that says hello Talmo, colon, and then I see something that appears to say y equals x squared. It seems that perhaps this has been rendered correctly. It seems perhaps the mathematical content has been converted correctly. That's good news. One of the things that I like to do in testing, you know, early tests of mathematical content on web pages is to kind of have a look at the context menu of the mathematical content. I right click on it because that tells me if it's been rendered with Mathjax. Because if I see the Mathjax context menu, I know that, you know, perhaps something behind the scenes is you know, either LaTeX or MathML. But when I do that in this case, I don't see the Mathjax context menu. In fact, I just see the Google Chrome menu. So that's interesting. Well, let's have a look at the source. I can do that in a few different ways, but in Google Chrome, I can press Control-U. And I look at the source and I see it says, hello Talmo, colon, and then I see some spanning elements for Y and for X. That's interesting. So that is not MathML. So I'm sort of interested in what screen readers will do. So I'm going to launch a screen reader now. So this is where we really start to push the boundaries of internet conference calling. We have tested this, and my goal is to get your screen reader not only to read out to me here on my laptop, but also through the internet to you back at home. And we're going to try to get JAWS to engage with mathematical content. So off we go. I'm launching JAWS. Just let JAWS launch here. And Michael, I'll be asking if you hear it. 1 second.
JAWS Professional, Talmo1.html-Google Chrome.
Michael, did you hear Jaws? Oh, great, I'm getting the thumbs up, thank you. So I'm assuming now that everyone can hear it. I'm just going to click refresh, and our goal is to get Jaws to read aloud the mathematical content.
F5, hello Telmo colon y equals x2.
Hello Telmo colon y equals x2. Now, if this is the first time you've heard a screen reader technology, it's a bit of a strange experience. So I'm just going to go through this a few more times just to try and allow you to kind of calibrate to it.
Hello Telmo colon y equals x2.
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 All right, so this is not good news, right? Because we want this to be read out as we would read it, which is y equals x squared. So the problem is that we are not rendering this using MathML. The default application of Tech4HT has rendered this using spanning elements, which might be fine for visual users. But if a user of assistive technology was coming to this, if they have to do, it's not reasonable to assume that they can interpret y equals x2 as y equals x squared. Like, what if it's actually y equals x times 2 or as something else? We need it to be read as we would intend it to be as mathematicians. So let me close down JAWS real quick.
5, Telmo, JAWS professional, JAWS, Alt F4, hello Telmo colon y equals x2.
And the way that we can configure Tech4HT is by using configuration files. So I've opened telmo.config here, and this is a very minimal configuration file that we are intending to connect in with Tech4HT. You'll notice here that I've called the first command preamble with xhtml and crucially mathml. And then afterwards, I've configured the head. And if we think of the body of an HTML and above that is the head, I've configured the head to load the most recent version of Mathjax. Then I said begin document, and then I said end preamble. So it's a very minimal configuration file. So to get this connected in with Tech4HT, we return to our PowerShell. The command I ran previously was make4ht talmo1.tech. To get this moving with this configuration file, I do -c for configuration, talmo1.config. I set that off running again. Make4ht by default is not very verbose, but we can get it to be so, should we wish to be. I'm sorry, it's not talmo1.config, is it? It's talmo.config. That was my mistake. Thank you, Make4ht, for the error reports. That's very helpful. That was not a deliberate mistake. We run through, and now we return to talmo1.html. And we click refresh. That's a little bit unfortunate. Let me just and let me cd into this. We'll run this one more time. And I think we were having problems with the associated auxiliary files and log files. And now we return to talmo1.html, and we perform the test that we did before. And I right-click on the mathematical content, and I see that it is indeed rendered with Mathjax this time, because I see the Mathjax context menu. So let's examine the source code and see if the mathematical content has changed. I look within the source code and I see hello Talmo, colon, and then I see math, and then I see the call to the mathml schema. And I'm seeing mathml elements within here as well. So this is giving me cause for optimism. I'm now going to perform exactly as I did before. I'm going to launch JAWS and sincerely hope that we get this to be read as mathematicians would like to read it. So let's wait for it just to launch.
JAWS Professional, Talmo1.html Google Chrome.
Okay, so we are
F5, hello Talmo colon blank. Y equals x squared math content.
Y equals x squared math content. Let me go back and just allow us to calibrate to this.
Blank, hello Talmo colon blank. Y equals x squared math content.
Y equals x squared math content. And whenever I hear math content from JAWS, I know that I can click enter and I can launch
Talmo1.html Google Chrome Math Viewer equation navigation. To move between partial expressions, press the arrow keys. To interact with the table, press enter. Y equals x squared.
So Math Viewer is something inbuilt into JAWS, and this allows us to interrogate the mathematical content at different levels. I can now arrow between these different terms.
Equals x squared, x, 2 exponent, x squared, equals y, equals x squared.
So I can now navigate between the different terms and interrogate them at different levels using JAWS inbuilt Math Viewer. Let me close down
Windows pop
JAWS
seat 5 20 minute zoom. JAWS professional. JAWS Alt F4. Math Viewer equation
one more
navigation.
example. And the final example that I'll go through is talmo2.tech, and this uses the AMS math package, and then it uses the Align environment. So this is something that we would typically expect to be using within our educational materials. So I will return to my Windows PowerShell. I will now call make4ht in exactly the same way, except I'll call it to operate on talmo2.tech. I will hope that I will get the associated status call from make4ht. And I will return to the file browser. I will be looking for talmo2.html. And there it is. I'll open talmo2.html. I will right click on the mathematical content. I will see it's rendered with Mathjax. We could look at the source and see that it is indeed MathML. I'll just launch JAWS again. And we'll try to get JAWS to engage with this mathematical content. So this will be the last time.
JAWS professional. Talmo 2 F5. Hello Talmo :X.
Hello Talmo :
Blank. Table with 2 columns and 2 rows math content.
Table with 2 columns and 2 rows math content. So if I click on enter, I can now explore it.
Talmo2.html Google Chrome Math Viewer table navigation. To move between cells, use the arrow keys. To return to the parent equation, press escape. Table with 2 columns and 2 rows. 1. Column 1 of 2. Row 1 of 2.
Table with 2 columns and 2 rows. 1. Column 1 of 2. Row 1 of 2. So if I navigate across, I will get an update in the column.
Equals 2. Column 2 of 2.
Equals 2. Column 2 of 2. If I navigate down, I will get an update as to the row.
Equals 4. Row 2 of 2.
Equals 4. Row 2 of 2. And so on and so forth. Let me escape out of this.
Escape. Math files to move to JAWS professional. JAWS professional. Alt F4. Math content. Table with 2 columns and.
So really what I want to demonstrate here is kind of this process, this cycle of kind of producing and testing, but something that really we're not going to get a chance to talk about today, unfortunately, and maybe it'll be, you know, the talk of a future session, is that things actually do get quite a bit more difficult from here. So I've demonstrated to you proof of concept and success in navigating around mathematical content. But in the extensive testing and development that I've been leading on over the last few years, we have actually found a number of cases in which JAWS would struggle to read mathematical content. And that has opened up a line of communication with Freedom Scientific, and, you know, I found fixes to get around it. But just to give you an idea of, you know, this has been used on much larger scale other than just these kind of little toy examples. This is an example of the type of file that we used in testing in consultation with the Royal National Institute of Blind People last year. So it's a sample of our module materials in which we have all kinds of definitions, subsections, sections. We have all kinds of exercises, examples, figures, and so on and so forth. We've also recently deployed it on one of our postgraduate modules, which contains all kinds of interesting differential calculus. But I think the main thing that I'd like to try to get across to folks is if you're not sure where to get started with producing alternative formats from LaTeX source files, I'm hopeful that the make4ht process that I've demonstrated here has been helpful. I would also really like to encourage folks to take ownership of the testing. One of the big lessons learned and one of the big mistakes that I made in the early parts of it was that I kind of deployed or relied heavily on others in the institution to do the majority of the testing for me because I didn't have access to a screen reader. You can get the free version of JAWS, and NVDA is free, and indeed you can bid for a license for JAWS and do the associated testing, and that was a really big lesson learned for me. So just in finishing off, I suppose, looking ahead, as the School of Maths and Stats, we are going to continue to prioritise accessibility and the associated student support, and continue to communicate with experts across the institution and indeed the UK, and hopefully, you know, learning from and contributing to best practices. So I'm going to stop talking now, hand back to Michael. And Michael, I think you're going to talk me through which questions, if any, you would like me to try to respond to.
Absolutely. I think firstly, thank you very much indeed for that, Chris. I think not only did you navigate the different versions of the technology superbly, but I think that was a really fantastic and accessible account to help people get started, to try these kind of things with their own teaching. So I think really thank you very, very much for that. There are a number of questions coming in, and I'll kind of try to cover as many as I possibly can. But the first question comes in from Amanda Minter and says, can you comment on good practice for writing figure descriptions of data visualizations?
Yeah, this is really interesting. So when I think of data visualizations, then I'm thinking of discrete points, scatter plots, that kind of thing, right? That's something that requires tremendous delicacy and care, right? Because quite often the learning objective is to try to get the student to to see if they can spot or figure out if there are any trends. So it requires tremendous skill in not giving the game away in terms of the learning objective, right? So your figure description wouldn't want to say there appears to be, positive correlation, for example, depending on the learning outcome. So explicitly, to try and give some practical tips. So we normally start with axis description. So vertical axis, horizontal axis. Have you got a label on there? Label, ticks, and then can you describe points? Can you describe the points in general without giving the game away? Are there any particular outliers that occur to you? Our experience has been that tactile diagrams come into their own for those, and we have also done some work on trying to turn them into sound as well in sonifications. I'm not sure if that gets somewhere towards responding to that one, Michael.
No, that does, I think. Thanks, Chris. There's a question you mentioned this is from Vincenzo Mantova, where you mentioned the accessibility package itself. And Vincenzo's saying that they've tried this within their sort of own experiments, but found it only tagged equations, and it was a lot of kind of additional work to tag paragraphs. Is there anything you can kind of share on your experience of using the accessibility package?
Yeah, I'm happy to share my experience. I was able to replicate the results as I understood it from their associated paper. And it was certainly a massive improvement on trying to access material within the PDF without the package. But no, I wasn't able to do the types of things that have been asked in that question. And the things that I also struggled with were, so when you access materials using HTML, it very much when I access HTML using JAWS or NVDA screen reader, I'm very much able to access the structure of the page. So I'm able to navigate around by heading, if I've got an enumerated list, I can navigate by item with an enumerated list or bullets. There's also ARIA regions on the output that I showed you here today. I haven't shown it to you on on the actual output that we use, but there's ARIA regions as well. And those were some of the things that I wasn't able to get working from that package. So that's why I decided to focus on HTML with MathML.
Brilliant. Thanks, Chris. There's a couple of kind of related questions here about accessibility for kind of video content. Now that hasn't been the kind of the focus here today, but taking the kind of the more general point, this is from Jitesh Gajar. Whose responsibility is it to ensure the online accessibility of content? Is it individuals or institutions? So you gave a kind of a great overview, Chris, of the legislation. Who does ultimately responsibility rest with for making any content accessible when it's online?
Yeah, this is definitely this is definitely at the heart of the issue. And I mean, ultimately, my understanding is that it'll be the institution, but the institution must have. I think it's my understanding that we as an institution must put things in place so that the teachers have access to the resources to get that done. And we're having exactly the same questions done around our associate lecturer community. So ultimately, it sits with the institution to make sure that the necessary support and technology is in place. It is my understanding, but happy to be corrected on that.
Thanks, Chris. And that would be, I think, my understanding from having looked at this as well, that we all, have a responsibility to make things accessible, but ultimately the accountability rests with, I think, institutions themselves. There's a related question from Sam Firm, which I think is a really good one that sort of builds on some of the things you've been discussing. That, and he asked the question. Sam asked the question: what's the best method for content authors to test the visual accessibility of their documents, assuming they don't have any visual impairments themselves? So, how can colleagues kind of test that their materials are accessible if they don't have their own visual impairments?
Yeah. So, what? So, are you? How could colleagues what? So.
Yeah, so when kind of colleagues, if I read this correctly, so when colleagues have kind of authored, their learning materials, how can they kind of go about testing that they are accessible to learners if they don't have any visual impairments or use?
Oh, right. Yeah, I guess the phrase that sticks with me that I heard quite a long time ago, which has really stuck with me, is "nothing about us without us." Yeah, I'm not a visually impaired person myself, so me testing the software isn't really an accurate representation of how a user would use it. So I would, if possible, if you have access to folks that can test it for you, who would be relying on it, that's always going to be the best way of testing it, I would say.
Okay, and I think take this as the sort of the final question, and then there's one comment that I will read out that's here. Martin Lopez Garcia asks: is Mathjax preferable to MathML? Okay,
so the things that I showed you today, the screen reader experiments, I did have the mathematical content rendered using Mathjax, but JAWS does not rely on Mathjax in order to interpret it. JAWS is analyzing the underlying MathML. So I could repeat the experiments for you today without Mathjax being loaded. It's the MathML that's the key part for JAWS. So Mathjax is the renderer, and the MathML is sitting underneath it. So for JAWS, it's the MathML that's vital. But we're assuming that the output that we're producing is not only for blind or visually impaired people, so we render it using Mathjax. For the NVDA experiments, which I haven't taken you through today, the use of Mathjax is a lot more important.
Brilliant. I think we've hit 3 o'clock there, and I think, Chris, you very much earned a cup of tea or coffee or whatever you may desire after that particular session. There's a comment here from David Leppanen where he gives a really kind of honest and thoughtful account of his experience of supporting a visually impaired student. And I'll leave you to kind of read that one after we kind of end, Chris. But I think David's point here is about actually where you do have visually impaired students in your group, that importance of engaging in dialogue to see what are the best approaches, because I think David's view here is that he has found when working with this student that you adapt and you change your approaches and you do things in different ways. So this isn't just a case of kind of one way of doing things, that if you have learners, we need to kind of react and adapt to their different circumstances.
Absolutely, yes, absolutely. And yeah, during the discussion about tactile diagrams and figure descriptions, I'm not sure, I can't remember if I said it now, but yeah, so that's definitely been an ongoing thing, has been to engage and try to meet the student, where they are and what would be helpful for them.
Brilliant. Well, I think we will end it there. I think we will say many thanks again to Chris for, again, a fantastic session. There's a comment here from Julia Gadecki saying, can Talmo do anything to kind of make connections between people with expertise in these areas? Please do remember there are kind of a number of mailing lists. There's the HE Maths TL mailing list where people can kind of post things, build some contacts. But if you've got particular things that you would like to share, please do get in touch. I think one of the wonderful things about our community is people are always willing to share ideas, and you see that on many mailing lists that people, there've been queries this morning that were posted out and people have answered immediately. So maybe we'll kind of circulate details of some of those lists for colleagues to use. But finally, I think to say thanks to Chris again. Thanks to everybody for participating. We'll look to get these materials online in the next few days, and please do share them with your colleagues. But once again, thank you to everyone. Thanks to Chris. Thanks to Rachel and Kevin for all their work pulling all of this together. Thank you.